Imagine you have built an application level rate limiting using various technologies, but you are facing some problems. Like, imagine your team grows. How do you share that rate limiting config with various other teams? How do you apply this at a global scale? That is where infra level rate limiting comes in. Hey friends, welcome to the channel. If you're new here, my name is Kaushik and I make videos about system design, but with a slight twist. Every week, I upload videos around practical system design where I try to wire in a few components and then see how they work together. So if you're interested, stick around and I'll show you how to build an infra level rate limiter. This is the third video in the rate limiting series, and in the previous couple of videos we saw how to implement rate limiting at an application level. We saw Python, Golang, Redis, and also some in-memory rate limiting. Even though it was simple to implement, it suffers from a few downsides, like you can't share rate limiting across applications in a distributed systems. You can also not share it with across teams in a larger organization. You would have to repeat the config, and even if you want to scale it out, or if you want to do rolling restarts, like when you want to change rate limiting without actually changing the config or without actually restarting the application, you won't be able to do that. So these are some downsides that the application level rate limiting suffers. So this we will be solving using infrastructure level rate limiting, and we will look at a proxy called Envoy proxy that achieves this. Let's dive in. Imagine that this is your application server. This is where all your business logic, your database calls, and also your rate limiting logic will typically reside. Now, if this is an in-memory rate limiter and if you have a container restart, then your rate limits might reset and the users can abuse the system for a small period of time. Now, also, if you have decided that you want a new microservice that you want to build, but you wanted to do it in a newer language, so eventually what you will have to do is copy the rate limiting logic that you have in a previous microservice in a previous language, and you have to make sure to port it to a new language, and then you have to maintain that, update it at two different places. Now this problem can get out of hand very quickly as you scale more and as you have more polyglot microservices. This is usually how large scale distributed systems are designed. Also, if you are a site reliability engineer in your organization, and imagine you have hundreds and thousands of microservices inside your large org, and you want to apply global rate limiting across all your services in the organization, app level rate limiting is not going to help you with that. You can clearly see that you will have to depend on various teams, coordinate with them, and then make sure that they are also updating their rate limit config from time to time. This is where infrastructure level rate limit really shines, and we will see how to leverage Envoy in this case. Envoy is a high performing distributed edge proxy that was written on C++ and originally created at Lyft. It has been built on various learnings of HA proxy and Nginx, and it's a universal data plane that can be used for various distributed applications. It is also used at various tech companies like Google, Amazon, Microsoft, and Stripe, to name a few. It provides a lot of robust features and advantages, like it can run alongside any application irrespective of the tech stack. It also has HTTP 2.0 and gRPC support built in. It provides robust APIs for configuration management, where you are able to dynamically push config to Envoy without restarting the Envoy server. And you can also monitor L7 traffic or wire level traffic using databases like MongoDB or DynamoDB. So this is the Envoy YAML configuration file. There are a few things going on here, and I'll go through the few important bits and pieces. You can also look at documentation online, and there are also a lot of resources in terms of courses and other videos that offer you a very in-depth understanding of the Envoy proxy. So let's start. So this is the admin block where sound like an admin block in the college, but yeah, so this is where the admin level stuff happens. You are able to monitor the Envoy cluster as a whole, and it is running on 8001 port. Static resources are basically backends or the applications that you are configuring and tell how to route traffic to these applications. So in this case, you're using the load balancing load balancing algorithm of round robin, and then you have strict DNS, and this is the name that you are giving your services. So one is the rate limit service, which we'll configure later in a second. The mock service, which is basically like a small application server that we have, and Envoy has given us a way to configure that as well. So this is another Envoy container running basically on 9999 port, and this matches the prefix of / which is any API, and then just quickly returns a response of 200 in hello world. So this is your classic example of your application level configuration. Now, if we scroll down a little, this is again the Envoy's configuration. It listens at 8888 port. So localhost colon 8888 will hit this main Envoy cluster. Then we have a couple of filters configured here. One is the HTTP connection manager, and the second one is the configuration related to rate limits. So we are telling it that you are supposed to contact the rate limit service or the cluster which we defined above, and then you are supposed to use gRPC, and below that we actually have the route configs for rate limiting. So this is where all the magic essentially happens. So it is going to match any API that ends with /limit, and then it is going to call the cluster mock, but before that it is going to apply a rate limiting to it. So here what we are essentially doing is we have a header name and a descriptor key defined. So the header name is what Envoy will extract from the HTTP request, and it will assign a descriptor key. A descriptor key is nothing but like a tag. This will later be referenced in the Envoy's rate limiting config, and then these descriptors will actually occur in the Golang application that we'll see later on. So if you check the example configuration for Envoy rate limiting, this is again, there is a lot of configuration that the GitHub repo has given us by default, but the ones we are really interested one is right at the bottom. So this is the one that I added. So notice you can see the key here. So this API key matches the descriptor key here. Now it is very important that you match this, and this is how Envoy's rate limiter service will apply your rate limiting logic. So again, I have specified that 1 requests per second, and then later on we will see how this all comes in together using Docker Compose, and then we'll try to call the API and see how that is rate limited. Okay, let us do some testing here. So we are bringing all the components together with a Docker Compose file. Again, the repository that's there on GitHub has done a very good job in wiring up all the components and giving us a good mix of all the services and how they come in together so that we can learn and understand and also extend the rate limiter to our own bespoke needs. So let's see how that all works. So again, we have the classic Redis here listening at 6379 port to store all the cache keys and all the values here. Stats_t, this is for exporting all your statistics, and you can see that we have a lot of metrics that are going on here. You can look at various counters like how many 200s you've received, how many 500s, 503s. You can also obviously add a lot of other status codes as well. You can see how many times you have rate limited your APIs and things like that. So again, very useful in a distributed system scenario. This is the rate limit application. Again, the image is Envoy proxy / rate limit master. You can download it from the Docker Hub, look into the code, and you can make changes, push it, and use it in the way you desire. There are a few ports that it's running on. So I think the main one is the 8081 port, which I think that's what we have configured somewhere here, if I'm not wrong. Yeah, that's the 8081 port. And then later on, you can see that this is a rate limit XDS config server. So this is an additional way of configuration, which is a dynamic way of injecting the rate limit. So instead of configuring them on a YAML file, you will be able to give them on code, and it's very easy to manage it that way as well. And if you have a lot of complex configurations, that's how you will go to. This is the Envoy proxy. That is the top level distributed proxy that we have. There are a few things that go in. So there's a log level that you're talking about, and what's the command, what is the level of concurrency do you want, the volumes here which talks about where is your config located, which is this, and then you are putting it into the etc/envoy/envoy.html network, and then the 8888 port where the Envoy runs, and I think the 8001 port is for the admin interface. The Envoy mock, again, this is like your application server. It runs on 9999 port. I've created a small shell script here. All this does is call your 8888/limit API, and it passes the header key, X API key, and my API key. Now we'll see how this is important in a second, and how the cache key is generated based on these values. All it does is call it inside the loop. It calls it 15 times, and then it just prints the HTTP code, which will either be 200 or 429. So let's start this. So we have a Docker Compose going on here. So I have passed in the Docker Compose example. -- build flag is to say that I want to build up all the images. Now I think I have all the images built in, so it should start pretty quickly. So there you go, all the containers are created. There's a bunch of log that print. So finally we have the rate limit service up and running. We have the Envoy proxy up and running, and we also have stats_t, Redis, and the Envoy mock that's up and running as well. So let me go to a newer tab and just hit limit check.csh. So you can see that only one request was going through. Since we have the limit of one request per second, most of the requests were denied and we got 429, which is a rate limit exceeded. So if you see the logs here in the Docker Compose, you can see a few things are going on here. So this is how it starts. So when it is coming for a lookup here, so this is the API key, the descriptor that we saw in the previous section of the video, and this is how the rate limiter is able to identify what are the rules and how I am supposed to apply it. So since we have configured one request per second, that's showing up here. It's doing a cache lookup. It is then constructing a key using the domain, and this is the descriptor key. And this is actually the header value that we passed in, and I think this is the timestamp. And based on that, it tells you what the current count is, and then it determines whether if this is over limit, and then it will, that is the status that sends, and we see 429 wherever we call the API from. So now we have moved our rate limiting configuration outside the application layer and into the infrastructure or the edge layer. But still, you can see that the rate limiting configuration is inside a YAML file, and this will not help us to scale across the organizations or will not help your infrastructure teams to apply this at a global level. So what do? This is where the classic control plane architecture comes into play. Now, loosely, control plane is nothing but how we forward packets or how data is actually forwarded. And the data plane is what actually forwards or applies the configuration. So in the context of Envoy would be a data plane, and Istio, which is another service that sort of combines all of this together, acts as a control plane and uses Envoy as its data plane. So Envoy offers these thing called extensible discovery services, and they are nothing but a list of APIs that anyone can implement in order to become a control plane. So these can be clusters, listeners, routers, certs, etc. So what I mean by that is you can determine what backends that you have configured, where they should be located, what are the load balancing algorithms that I should use, what are the various certificates, and how to rotate certificates without actually even reaching the application level. So this is how the control plane and the data plane architecture interplays together. Now, rate limiting service that we saw earlier does not exactly fit this paradigm, but you can still see that this gives you a dynamic way to configure rate limiting. So imagine a classic use case where you have a free tier and a paid tier. Now, this is not something that you will be able to configure in YAML, as there are a lot of users, and as your application scales, you cannot add all the configurations in the YAML files. So how do we do this? So for this, let us look slightly deeper into the Golang application that the Envoy proxy has built for us. So this is the rate limiting application. There are quite a few things here, but I will go through the main areas which you will have to concentrate on. So this is where you see that the rate limit.go file is, and the should rate limit worker is the main function that you are interested in. So it takes a list of descriptors that we saw earlier. So it comes from the YAML file. So you will still be defining a descriptor in terms of what your header key should be, and the values will be injected dynamically. So these are the descriptors that come in. And then if you scroll down slightly, you can see that this is where you can implement whatever logic that you want. You can call external service. You can determine if this user is a paid user or a free user. And then you can either say that they are over limit, or you can send them a response code of 200. Depending on how the user or the data is structured. Another thing to look at here is how we generate cache keys. So this is where your cache key is getting called. So you can see that the domain and the descriptors are passed. You're also passing the limits, and you're also passing now, which is basically the timestamp. So if you look into this method, you can see that the prefix is added. I think we did not have any prefix, so that's just empty. The domain, which was actually RL, and then there's the underscore. The entry.key, which is basically the value or the key of the descriptor, and the value of the descriptor, which was the value of the header. And then we have the underscore, and then actually the timestamp that was printed. So this is how the cache key is actually generated. So if you want to change how you want to add, so if you want to add a user ID, if you want to add some other unique identifier for a user, this is how you would do it. And then if you also look at another important thing, which is settings here. So this is basically a very comprehensive configuration that you can give to the rate limiter. So in terms of what sort of log level you want to have, what sort of logging format you want to have, this is all your gRPC configuration. If you scroll down a little bit, you also have various extensible discovery services. So this is how, like I mentioned, you can extend your rate limiting configuration again. And then you have a few things here. So this is the Redis again, so very important. You can use Redis, which can be, just a single Redis. You can use things like clustered Redis, and this is where you would specify your TLS. You will specify how you want to give in your client certificate, CA certificate. So this is in your real life scenario, you will always have Redis under a TLS or SSL enabled. So you will have to provide client certificates and CA certificate so that your rate limiting server is able to connect via SSL. So let us recap. In this video, we saw application level rate limiting and also infrastructure level rate limiting, and we compared the pros and cons of both approaches, and we saw how you can apply these rate limits at an organizational or a global level. We also saw Envoy, its configuration options, and also its rate limiting service. We also looked at the control plane and data plane architecture and looked under the hood of the Envoy's rate limiting service, and also saw how we can implement our own caching keys and also how we can implement our own strategies for rate limiting in terms of free users versus paid users. I will write a blog post soon talking about all these concepts in detail and will post the link in the description down below. If you like this video and want to see more videos like this, make sure you like this and subscribe to my channel. Thank you so much for watching and see you in the next one.